Good morning and good afternoon. This is Andre Restaino. I'm the Managing Director for the ISA Automation Standards Compliance Institute, and I'm the Staff Managing Director in charge of the ISA Secure Program Operations. So I'll go through a description of the program, and at the end we'll be sure to allow time for questions and answers. So our agenda, a bit about the Institute, the structure of the scheme, 62443 standards, description of our certifications, and then a little bit about the roadmap, future programs. So the ISA Security Compliance Institute, sometimes called ISC, is a wholly owned subsidiary of ISA, set up as a separate company, a 501c6 not-for-profit. It stood up to create a consortium. It's operated like a consortia with memberships. Companies pay dues. We're managed by a governing board who set the strategy and direction of the organization. So today our chairman is Ed Crawford, vice chairman Johan Nye. We organize with a board-level liaison to the ISA 99 committee, where the ISA IEC 62443 standards are being drafted and published. And that role provides some oversight and confirmation that the certifications that are published at the Security Compliance Institute are aligned with standards. So we are a not-for-profit, so we do collect fees for certification logos / registrations. We also have memberships. Companies join and help with the development of the specifications, so they're stakeholders at the table. Any of the revenues collected go directly back into operation of the program or expansion and improvement of the certifications themselves. The list of supporting companies, we're pretty well represented in the oil and gas process industries. We have supplier organizations, labs. And interesting to note is a Big Four accounting firm, KPMG, in Japan has joined as well. So this is an indication of where the market's going. Operational technology, cybersecurity now is becoming mainstream and is a board-level topic. So you'll see the Big Four and the major consultancies are now addressing these things at the board level for the companies. So the scheme is set up as an accredited ISO IEC 17065 conformity assessment scheme. That means that the labs that do the conformity assessments are accredited independently by international accreditation bodies. And so they're accredited to ISO IEC 17065 and as a conformity assessment organization and accredited to ISO IEC 17025 lab operations. So to be clear, the Security Compliance Institute has not set up a lab and has no intentions to set up a lab. Instead, we manage the specifications and the accreditation, and labs that you all are familiar with are doing the assessments. And typically, we found that labs that are already doing SIL certifications, the 61508 and 61511, have the proper skill sets and profiles, and so they've transitioned to these types of assessments pretty readily. But the objective of the 17065 was that so that ISA Secure could scale on a global basis using independent certification bodies, and the certifications would have global recognition, and the ISO 17011 accreditation bodies ensure that the certification processes are open, fair, credible, and robust. So we've got MOUs with ANSI ANAB, the Japan Accreditation Board, and DAX in Germany to provide the accreditation services to bring on new labs. So I guess the big question is, why certify? So we're certifying the commercial off-the-shelf products. They're not site engineered yet. Essentially, we're looking at ensuring the security capabilities of the base products that eventually enter into site engineered solutions. So what we do is we independently assess and certify security capabilities of products, very similar to SIL certifications. The accredited ISA secure labs have subject matter experts who know how to do this and who are skilled in this topic area. So it reduces the effort for end users to validate and verify security capabilities. In many cases, cybersecurity experts just aren't on staff, or they're rare, or they're erstwhile busy. So having an independent assessment makes it a lot more efficient in the market. And the other key thing is that the standards establish objective security metrics. And so the IEC 62443 standards, they are organized with the level 1, 2, and 3 security levels, and labs assess to those security levels and give independent confirmation. The standards are important. They encapsulate and codify hundreds of years of subject matter expertise from hundreds of committee participants. And so it makes them extremely valuable documents and reduces the requirements for everybody in the marketplace to have all the expertise if they're following the standards. One of the things that I've learned along the way is that the conversation about certification requires context. And so the 62443 standards are organized on a life cycle basis, cybersecurity life cycle. So at the front end of the life cycle, suppliers design and manufacture the off-the-shelf control systems, which includes embedded devices and software applications. And then those reusable components are integrated by integrators and typically in partnership with the asset owners into a site-specific solution. And those are commissioned, turned over to the asset owners for operations and maintenance. And so you see the relationship between the three different parties here with the green arrows. But then as these systems are used in the, at operating sites, there might be vulnerabilities identified or other issues. And so there's feedback that comes back to the integrators and to the control system designers. And so also the security life cycle recognizes the shared responsibility between the parties in this life cycle equation. So, you know, I hear often that companies are 62443 compliant, and I ask, okay, to what standard? There's 13 standards, so understanding the organization of the standards is an important dimension to understanding how to use them. So at the top, the standards are organized with terminology and concepts, and these establish the context and the lexicons and the common vocabulary, the concepts for fundamental requirements. The next level down, the standards address policies and procedures. Typically, this is used by asset owners to establish requirements for their cybersecurity management system, and implementation guidance on standing up and organizing such a program. And also describes the relationship between the integrator and the asset owner. The 6443 2-4 standard addresses that predominantly. Patch management. Where the ISA Secure program operates is down at the bottom two levels. So there are requirements that the 3-1, 2, and 3 standards establish requirements for systems. It defines the zones and conduit model. And at the next level down, there are requirements for components. The 4-1 is the life cycle standard, the security development life cycle for product developers, and the 4-2 is technical security requirements for the components. From a usage perspective, this diagram does a better job of showing which standards should be used by which group of interested parties. So starting at the bottom, you have the product supplier. They develop products using a security development life cycle. That's the 4-1 standard. And then the 3-3 standard and 4-2 address specific technical security requirements for applications, embedded devices, et cetera. So this is for the off-the-shelf components or products, if you will. And those are used by integrators and combined into a site-specific automation solution. And so there's the 2-4 standard, which addresses integrator practices and the relationship between the integrator and the asset owner. Then at the very top, again, the asset owner, there's a set of standards that provide background and assistance for standing up and operating the cybersecurity programs at their operating site. So again, ISA Secure at the front end of the life cycle. We're not trying to boil the ocean. Our focus is to test and secure products that are being developed by the suppliers, and we're certifying to a set of standards. And so hopefully those products will then provide a good foundation for use in an integrated solution. So we have 3 certifications available. The first is the Embedded Device Security Assurance. That's a product certification, and it's intended to certify to the 4-1 lifecycle standard and 4-2 technical requirements for components. The next level is, the next certification is also a product certification. Certifies to the 3-3 standard, and you'll notice that it also includes 4-1. There's a life cycle for system integration, and 4-2 it's also included. So when a system's evaluated, the embedded devices and components are tested as part of the overall evaluation for systems, and the integration life cycle is evaluated as well. As part of our product certification, there's a security development life cycle evaluation that occurs on a product-by-product basis. So typically, a supplier who has a portfolio of products, they'll want to have their security development life cycle for their product development organization evaluated and validated. And so this would happen one time and then be reviewed and reassessed on a periodic basis, say every 3 years. And so our auditors will go to a supplier's development organization and review their declared life cycle, and then audit, go through and do a tracking to confirm that that life cycle is actually being followed at that developer organization. So having a security development life cycle, a formal life cycle implemented and used is quite an undertaking. So to achieve this certification is pretty significant. There's a lot of value in it, and today Schneider Electric, they're the first to achieve the SDLA, and they've actually gotten 3 sites certified to the ISA Secure SDLA certification. So, okay, so the certifications themselves, the embedded device security assurance, that's the first one we'll talk about. So we certify devices. The question is, what's an embedded device? It's a special purpose device running embedded software designed to directly monitor, control, or actuate an industrial process. So that would include PLCs, DCS, RTUs, SCADA systems. So the systems, some of them actually do control and actuation, and we've actually certified a device that does monitoring only. So it covers the gamut. So the result of an EDSA certification, we do 3 major things. We certify the product's robust against network attacks and free of known vulnerabilities, and it's intended to certify to the 4-1 and 4-2 standards. And the key thing is that it's an independent certification of the product's security capabilities and security levels defined by 62443. So, again, the analog is SIL certification. So today, companies that are procuring safety systems, it's pretty standard business now that you want the safety system SIL certified, and in your procurement specs you say SIL level 1, SIL level 2, or SIL level 3. So that's what where this is headed. So there's 3 levels of certification for embedded devices. So what actually happens in EDSA certification? Well, there's 3 categories of activities. There is an audit, there is an assessment, and then there's some tests. So the audit is for the security development lifecycle at the product development organization, and the intention of that is to detect and avoid systematic design faults. And so this ensures that the development organization is following a robust secure development process. A functional security assessment's done, and this is where this is another area where specific requirements from the 62443 standards are involved. And the objective of this is to detect implementation errors and omissions. So we're looking for the functional security capabilities in the system. We're assessing them against the functional security capabilities defined in the standards, and at the end, the supplier is going to receive a certificate that's going to indicate security level 1, 2, or 3. So we also test the products for known vulnerabilities. So we run a Nessus scan. That's our vulnerability identification test. And so we scan using the U.S. CERT National Vulnerability Database as a reference. And so the scans are date and time stamped so that the certification, the certificate of conformance that's issued indicates which version and date of the National Vulnerability Database was actually used. That way, in the future, say if a certification was done at the beginning of the year and a company's seeking to procure a product, they can make a procurement requirement for the supplier to run the vulnerability scan again just prior to acquiring or factory acceptance test time, et cetera. So we also do a communication robustness test, and this tests for vulnerabilities in the lower 4 layers of the OSI reference model. And so there's fuzzing done, broadcast storms, unicast storms, and any IP addressable devices are attacked using the CRT tool. So ISA Secure for systems, again, this is the system level security. The key standard here is the 62443 3-3, and It also includes requirements in the security development lifecycle that apply to systems. And as part of the system security assurance, again, the embedded devices are tested. If they don't have a ISA secure certificate, they undergo the same sets of tests to confirm their security capabilities. So similar to EDSA, the SSA confirms the product's robust against network attack and free of known vulnerabilities, and meets the 62443 requirements, and it's an independent certification of the product security capabilities as defined by the standards. So the certificate will issue a level 1, 2, or 3 for it. One of the toughest questions is defining a system. So for the purposes of the conformity assessment scheme, we say it's an industrial control or SCADA system. It's available from a single supplier, supported by a single supplier, and that could be a system integrator. It doesn't have to be the component company itself. System integrators put together systems from a number of suppliers and sell them as an end product. So again, the components are integrated into a single system, and the system can be comprised of multiple security zones, for instance, a process control zone and a process safety zone, and identified by a specific name and version. So these systems are off the shelf. They haven't been site or project engineered yet. And the evaluation is done using the 62443 zones and conduits model. And so each of these zones could have a different security level requirement, and this is taken into consideration as part of the system level cert. So what actually happens? So again, there's as part of the audit, part of the assessment, there's an audit of the life cycle, and there's an assessment of the security capabilities of the system, and then the system is actually tested. So we do system robustness tests that consist of network robustness testing and system robustness testing. So it's a structured penetration test at all external entry points on the system. We also scan for known vulnerabilities using the Nessus tool, and that goes against the National Vulnerability Database. So the third certification that is offered today is the Certified Development Organization. I described that briefly earlier, but this is an organizational certification that a company's specific site meets security development lifecycle requirements based on the 4-1 standard. So this review and certification confirms that the development sites have work processes that include security considerations throughout the life cycle. It's site-specific, goes against the 4-1 standard, and it was based on several industry-recognized security development life cycle processes. Our original draft on this certification was based on the Microsoft SDL, which was edited and updated to include requirements for operational technology for control systems. We have permission from Microsoft to use their base SDL in this certification, and when we drafted the certification requirements, we had their experts independently review it and provide input on our final draft. So we use 12 SDLA phases. So it includes everything from security management process and security requirements down to what happens out in the field, security response planning and execution. So If an end user sees something unusual or identifies a bug in a product that's out in the field, the development organization has a response plan for triaging what occurred out there. Is it an operational error? Are there process discipline issues? Or is there an actual product issue that may require a patch and notification and patch release to anybody using that product? So the security levels and the certifications, security level 1 through 3 for the products, and it goes up to level 4 for process. So at each level there's an added level of functional security requirements and the same an added level of rigor in the secure development life cycle. The numbers of requirements increases as you go up the security levels. The security levels, higher number equals higher security. Not only do the numbers of requirements go up, but the types of requirements become more rigorous, such as static code testing and dynamic code analysis in the software processes. So how would you use ISA Secure in procurement or the 62443 certifications? So the asset owner initially would assess the risk and determine the required security levels based on the standards. And the objective would be to identify and require COTS applications that would meet those security levels. So an asset owner would review the ISA certification requirements, noting the security levels, and confirm that they either need a level 1, 2, or 3, and specify that matching security level in your procurement document. And if you have any company or project-specific additions that are over and above or outside of what's been defined in the standard, you would add that to your procurement documents. So it'd be the ISA Secure SSA requirements, for instance, from the website, and if that's sufficient, then that's it. Or you may have some additional corporate standards. So today, here's a sampling of devices that have been certified. You can see they come from a number of different suppliers: Honeywell, Yokogawa, Hitachi, Schneider. There are additional products that are in the pipeline, and as they're certified, they're announced. They're posted up to the ISA Secure website, and also at the lab's website. For instance, if it was TUV or the Japanese lab CSSC, those certificates are also posted there, but ours is the controlling website for that. And today, Schneider Electric, they are the first company to have their sites certified to SDLA. So today they have 3 sites that have been certified to SDLA Level 1. We have a tool recognition process where we've developed requirements for the test tools, and we're able to evaluate the test tools through a process and ensure that they can be used by our labs for testing. So suppliers who are looking for tools that are also recognized by the lab, they can look at this list and identify which tools. So today there's four tools for CRT testing. Beyond Security, Hitachi, Synopsys, and WorldTech supply those. And we've standardized on the Tenable Nessus tool for doing the VIT testing, vulnerability identification testing, against the U.S. CERT National Vulnerability Database. There are other tools that are going through the recognition process. When they complete the recognition, they'll be listed as well. So the labs, if you will, are the certification bodies that are issuing certificates today. Exida, they're accredited by ANSI, NAB. They have global operations and their headquarters in Sellersville, Pennsylvania. The Japan Accreditation Board certified a Japanese government lab called CSSC-CL, and they certify products in Japan and the Asia-Pacific region. They're headquartered in Tokyo. We have another lab that's based in Germany. They're most of the way through their certification body accreditation. DAX is the accrediting authority in Germany. When that's completed, which we expect sometime this summer, we'll announce the availability of that lab to start doing certifications. So the roadmap, new work. One of the key items that we're working on is an application software security assurance, ASA. So that's underway. The basic structure of the certification's done. These certifications are very difficult, have a lot of thorny issues, but at any rate, that's a key work item. We stood up a building automation system study group. Stakeholders from Japan in particular pushed us to start certifying building automation systems. We think that our certification scheme works just fine for it, but we want to be careful to ensure that there's proper representation from asset owners and suppliers from that industry to confirm that 6443 in our certification scheme is appropriate for their needs. So that's underway now. We expect to issue a report by midsummer on that. We're collaborating with the European Union. They're standing up requirements for a conformity assessment program through the ERN-CIP. They will issue their own press releases about that status.